Now let's see if it works. Job going 0%. Okay, it's okay. We are live. Yes, we are. Okay. Alright, am I audible? Yeah, I think I'm audible. Let's see if you want to change some of these settings. Looks good. I'm not changing any of this. I'm just gonna start. I'm gonna mute this stream. I'm gonna keep this open, and then I'm gonna start streaming here as well. Okay, so this is Twitch profile. What is this? Goes around here. Minus 15. And where was this? This was minus 40.6. Hmm. Alright, I think we are live on both of these platforms. Alright, so here's what we are doing today. Yeah. Uh, so this is a global game jam project. Okay, first of all, let me just quickly go and come. My eggs are must have boiled. Alright, I'm back. Mm, mm, got some bread with cheese here. Alright, so what this is what we're doing here. This is from this is inspired by Junji Ito's hanging balloons. This was a submission for Global Game Jam. But I could not finish it because I felt sick as I was doing it. So I decided to come, but the project was like I had everything planned out, and the project was really interesting, both technically and as a game. So I decided to pursue it. Also, it's a short game, and it'll be a great addition to my portfolio. That's the other reason why I want to continue pursuing it. Yeah, something like this. So you see the hair are flying everywhere. It's kind of creepy. They're all white looking faces. They almost look like they were kind of porcelain face. They're very creepy, tired. Uh, we're trying to do that. Mm. So I got this. Okay, let me just remove this light for a second to show you how it looks right now. Right, the eyeball I'm gonna put later because the eyeballs are gonna be real game objects, like separate game objects, because I want them to look at player when the ghost is aggroed on the player, aggroed onto the player. So that's why I've not put eyes yet. But yes, but I've got the skin color right. The, this is the skin I want. These are the expressions and everything I want. There I have to do more animations for the expressions, but this is it so far. And the hair also I've figured out. These are rigged hair, right? So there are individual strands, uh, and each strand has a texture. So that's what it looks like. There are many strands, but there are only few strands here, like about 200 strands. And then each and the strand have this kind of a texture. That's what it looks like on the main strand, but no. So it's a bone rig, um, and yeah, this is the script for it. I've added a horror mode, which makes the hair kind of fly even without um, even so I wanted the hair to have inertia as the heads are kind of when the heads kind of aggro onto the player, that chasing the player. So I want the inertia, the motion to be applied onto the hair, the motion of the head to be applied on the hair. um, but then I also want um, them to be kind of flying like this, just to create a horror effect. So they're kind of air flying in the air, but I don't have. So I won't be having wind blowing that much. There would be wind, but not that much. This is just like an effect, and you can change it, right? So if I increase the speed, then you can see that the air is getting affected by the inertia, right? So that'll be pretty cool. So now what I want to do is I want to fix this issue. Not an issue. It's a feature that I've been wanting to work on for a long time, for the longest time actually. I was first introduced to this way back in 2016-17 when I wanted to make a game like TF2. Team Fortress 2. There's a paper on this, I forget. Shader. Let me just write shader. Oh, somebody has written a shader for this and put it on GitHub. That's crazy. But I want the original Valve paper. Hmm. This is the one. Oh no, we have some. We have a code also. Uh, I think this is HLS. No, I don't think so. There's any shader used here. Is there any shader used? No, it's just a CPU rasterizer. Yeah, it's just a CPU rasterizer. So I don't think so. This will help us, but these other things would. So yeah, this was the original. In fact, this is not even the original paper. There was a presentation that they had done in SIGGRAPH, which they had uploaded. I think that link is kind of dead. Valve has always had this kind of soft shadows. Even in Deadlock, they have even softer shadow. Actually, in Deadlock, they have even softer shadows. Like in Deadlock, the shadows don't even have a shape. Just blackness that represent the shadow. Engine branch, okay? This is not what we want. We're looking for that presentation that Valve did for the look of these characters. Lighting more models, not this. I'm just gonna close. Actually, you know what? This could be helpful because I know about this one. But I just wanna show you guys. Mm, I just wanna show that presentation to you guys. Actually, if I search it on Google, it'll be better. Let's see. Alright, if you don't find it now, this is the one. This is the one. Alright, let's skip all of this. Let's go to the rendering. All this is really interesting. You guys should look at this. The kind of decisions they've taken are so minute, but adding everything up, it actually does make a big difference. If like the summation of it is big. Yeah, all this rim lighting. But yeah, what we are doing right now is the half limbert. So you see this black area, right? Now the problem with Unity is apart from this, where is it? This. You don't have much control over how the light would react in these dark areas, and I don't like the way this looks. I've never liked this kind of way. Unity, actually, a lot of engines, standard shader draws the objects, draws the lighting, right? Because it kind of you don't really get the feel of the object, and it's a pitch black. You can see it's really pitch black. And to fix all of these like different engines, like for example, Unreal Engine does it has really nice uh, global illumination, but all that is because it's using deferred rendering. And if it wasn't using deferred rendering, then to get that quality of global illumination won't be possible. But I don't want to use deferred and global illumination because this game really does not require uh, that much realism. Um, and yeah, this kind of thing, these kind of problems are simple fix. So I could just use this. So what these people have done, they face the same issue. That as you can see, the as the light, like as the polygons face away from the light, they tend to become darker and almost unreadable. Like this area is not readable at all, right? So they and this is the Lambertian lighting that causes this. So what they are doing is they're using so they just divide this by two. They just make it half, and they call it the half Lambert lighting. Right. So now you can see this area is readable. It gives you a sense of global illumination, but oh sorry, this one. It gives you a sense of global illumination, but there's not actual global illumination. Um, and yeah, the other thing they're doing something called as warped diffuse. So this is the effect of that. This is the effect of warped diffuse. What that does is, um, yeah. So how they've implemented warp diffuse is they like in their shader you have to input this gradient, and this is almost like a lookup table, and it kind of multiplies your lighting with this, if I'm not wrong. Let's see the yeah. So this is the oops. This is after you've done the work. Yeah, it kind of gives a glow to the mesh, right? So the glow is defined by the gradient, and there are multiple gradients here. As you can see, there are almost three gradients, right? There's one here, then there's one here, and then there's one in the middle, and two at the end. And this is just like this also is a hack for subsurface scattering because the skin material, like the material for the skin needs to have subsurface scattering for it to look real and readable or good. Um, but subsurface scattering is a really expensive thing, and back then it was even more expensive for because of hardware limitations. So warp diffuse is kind of a hack for that. So what it does is, like, we don't want to use the gradient. Um, I've read it somewhere else also. What it basically does is, whatever the light is at this pixel, it kind of warps it um, around the surface, right? So this light is kind of warped around the surface. Uh, so it kind of makes the other areas lit. It kind of blends all of this to give a smoother look. So the brighter areas are a little more brighter because of this warping, and the darker areas are more lighter, right? See, as you can see, the darker areas are a little more lighter because of this warping. And like on a skin, like on an object which is purely just skin, it really looks like subsurface scattering. It really looks like it looks as if there is subsurface scattering. We can take a look at this. This is even better uh, explanation on how the lighting works in Team Fortress 2. So yeah, this is the warp diffuse. This is the so A B. 1 second. B plus C. Yeah. So this is the one that we have to do first, which is half Lambert. But I don't think so. Unity's standard lit shader is Lambert based. Let me just check. I have to first extract the shader files from the packages, from URB packages. But I don't. Yeah, it's not. It's actually not Lambert lighting. They're using BRDF. But yeah, I'm sure we'll find some solution for a nearer solution to half to this to half number in BRDF. So that's all. We are doing two things. We are doing the half numbered and we're doing warp diffuse today. Um, all right, let's see. So now what we have to do is you have to extract this, and you can kind of tell because you see this kind of a painting. There's not much darkness here, right? It's mostly just white. So that's why, and that is the reason why it looks creepy because it's flat and there are just harder details. There are no softer details. Like these finer details are all that there is. Um, yeah, it's gonna look really good on this. I put this light just to check. So I was thinking of putting more. So I was in the shader only. I was thinking of putting to lighting these areas, right? These kind of the areas which are facing downwards to put a little bit of light there to give that scary look. So that this light was just to test that, but I don't think so. I'm gonna do that right now. I'm gonna do it later maybe. Yeah, I'm gonna try to do something like this. All right, so let's get on to this. There's a lot of cleaning that I need to do here. Just clean all this up first. Are we not using the physics manager? Not. Delete these two things. I'm going to move all of this into my scripts folder. Yeah, I was actually speed running this project for GGJ. That's why the whole project is kind of unmanaged. But I'm gonna do that soon. I actually don't even know what I need, what I don't. Does chat appear here? How do I get chat? Literally just opens the browser here now. I want to dock it here. And then I also want the chat. I guess I'll just use this. Can I just dock it here? No, I can't. Alright. Can I get chat here in Twitch? No, I want to close this. I don't need this actually. How do I get the chat window? It showed when earlier, but I closed it. Alright, I'm actually fine with this. I don't really need to get chat that often. Alright, I'm gonna delete this. Save the scene again, and then why did I press save as? Save. And then we need the head, right? This need this shader. Actually, I need to press this. Select shader. It's gonna go in the packages. And there are just too many files you have to extract out of this. I had done it in my other project, so I know. I'm so lazy for doing this, but okay. Yeah, actually, you know what? I'm just gonna do it, and then put it. This time around, I'm gonna save it as save it in like a backup folder. But then the problem is that if they update the shader files, I won't get. I have to keep updating it every time they update it. But that's okay. Never mind. Alright, so we're gonna need a lot of files. But we're gonna start with this. This is the main. This is not the main file actually. Oh yeah, this is the main file. The dot shader file is the main file. And then we're gonna need, first of all, I'm gonna close all of this. You're gonna need. I don't know if we need this, but I'm gonna take it. Actually, we don't need this. Later, if we find out we need this, then I'll put it. But I don't think so. We'll need that. Yeah, we need this definitely. We need this. Alright, I'm just gonna start noting this down. Wait, actually, I'm gonna note it down. I'm gonna use this. Alright, so we need the for pass. Right, we need this. Then we need this. Actually, I'm just gonna eat all this up and keep what's needed. What is the other thing that I need? I don't know if I need dots.hlsf, but I'm gonna assume I don't. Then we need this. Not sure if I need the four-graded ending keyword. I don't think so. I don't remember needing that earlier when I had done this. Yeah. Oops. Whoops. How do I go back? Oh, pressing alt really messes this up. Alright, depth only pass. All these second lines below lit input, we need all of those. At least most of those. I'm sure there are a few that we don't need. Otherwise, if we don't put all this, then it kind of shows an error. The shader won't compile. Was it depth normal pass? Yes. Alright, let's go down. Lit meta pass. What is that? Is it for Oculus? Is that why it's called meta? Universal 2D. Why is Universal 2D here? Alright. I don't think so. These are needed. I don't think so. These are necessary. Alright. Yeah, that's not many files. But then we have to go inside each of these files and check because they're gonna have they themselves are gonna have some dependencies which we'll need to extract. Alright, wait a second. Yeah, all of these are in shader folder. That's great. Alright, so if we check this file, yeah, I don't think so. We need to extract all of this, but there's one thing that we need to extract because we are doing the half inversion. We need to extract that, and I think that is in forward pass. Yeah, this is gonna have lighting HLSL, and I think the way they have structured their shaders is that all of these things, like you can have all of these things are modular things. So so lighting, then the light. So lighting is a separate file, a separate shader file, which they import here. And then inside lighting, there's another file called light.hlsl, um, which is for each light you have. And then there's another called surface, and there's another file called something else. And there are files and files and files, and that's how they do it. And all of these they put it inside the shader library, and I think their paths are different if I'm not wrong. No, the other. I mean, it's inside the same package. I thought it's under a separate package because I wasn't able to find the library here. Oh yeah, it's here. Yeah, so BRDF. They're using BRDF lighting model. And if you open the lighting, then we'll know that they're using BRDF. And inside BRDF, I'm sure there is uh, the light.hlsl. Oops, not like this. Okay, inside that there's a BSDF. And BSDF is inside here. No, it's inside a separate package. It's inside the core. Okay. Alright, I'm just gonna see this file though. Let's first go back to the forward pass. Let's go to the fragment shader. There is the fragment shader. And let's see what we're doing. Alright. There is no coloring going on so far. There's coloring here. Universal fragment PBR. Alright, we have to find this function. Universal fragment PBR. How do you shift from tabs here? Yeah, so how do you do it? Does it paste? Yeah, it does. Yeah, so it's in the lighting.hlsl. Alright, now let's see which. I think we are using this one, and that calls this over here. Oh no, they are the same. No, they're not the same. They are separate, different functions. But we are, yeah, we are calling. I've done this before. We're calling one of this. We are the one with two overrides. Yeah, this one. And then this calls inside the call. There's the call to the bigger one somewhere. Actually, there's not. I was wrong. Oh, it's a deprecated one. Okay. Oh, okay. So I think they've wrapped all this inside that data structure. Alright, so we get the input here, we get the data, surface data, and then let's see how we're doing the lighting here. Clear code calculation. I don't know what that means. Shadow mask. Create ambient occlusion factor. Get mesh rendering layer. Get main light. Alright. We don't need, we don't apply AO to this because it's done. Okay. Alright, what does it even return? It returns the color, right? I want to trace that. Here it is. Now that goes under another function. I'm sure this is going inside BRDF. Worst come worst, we'll have to create a custom shader. Like an absolutely custom shader for all of this, but I don't want to do that. Wait, what? Sorry, this. Okay. Oh, it does not exist. Okay. Let's see what we're doing here. Yeah, I'm sure this is getting caught inside that. I mean, we could just use this. We'll take the light color from here for that pixel and then do our half inversion and everything here. Just like a hack, but I can do it in a cleaner way. I can create my another. I can create another HLSL and put that You create another file called halfnumber.hlsl and have my code over there and just call the function here and or wherever. Let's see. Calculate lighting color. I'm just gonna undo this. How do I undo? In Vim. Oops. Yeah. Why is it going in the editing mode? Okay, final color. Yeah, we found this here. Then we have to find the other one. Calculate lighting color. Hmm. Yeah, I'm glad that all of this is over here. Hmm. Is lighting feature enabled? Alright, what is this even doing? It returns a color, but the color is zero here. And there are like so many ifs. Okay. So at least this gets executed. If all of this is false, then at least this gets executed. Some of these are like debug calls, so we don't really have to look at that. All of these are actually debug. So this is all it does. Multiplies 0 with albedo. I mean, anything multiplied by 0 is 0. So this is 0 here. Alright, so it's not doing the real light calculation. Then, right? It's not doing real light calculation just yet. I'm gonna go to where we were. Oh, I think this is getting called first, and then this calls that in return, isn't it? Oh, we are sending the albedo. So yeah, this gets called then. I mean, depends on what this albedo type is. Albedo is a half three, so yeah, this is the one. This gets called. Yeah, and this is gonna be 0. So that means that this is 0, and then you get the mix form, and then yeah, that's the color. But this is, I don't think so. This is the final light. So where does light actually doesn't happen in this forward pass then, or yeah, or maybe I could be wrong because I don't know how the operations between two half three take place. I could be wrong here, but yeah, I think I'm not that off. I don't think so. I'm wrong. Uh, I don't think so. I'm that wrong because I think it should be just by each component. The multiplication. I think the multiplication happens by each component. I don't think so. It's like a vector multiplication. All right. So I see this function here, and I'm gonna find. Oh, this is used by the shader graph. Okay. Unlit. I see a Lambert function here, but I'm gonna skip it for a second. I'm just gonna go back to our original trace. which was calculate final color, isn't it? Universal fragment PPR getting called, and universal fragment PPR calls this. Oh, okay, actually, this is. I'm not sure which one. Yeah, let me try to find this in the BRD. Yeah, it's not here, so it is from this. Yeah, and we're sending the input data and surface data, isn't it? And surface data, that's correct. Yeah. Oh no, this is the decorated one. This is the one. Okay. Yeah, that looks like a method that would be in the bref.hlsf. But how does all this affect the final? Because I think it all comes down to this. If real is half, what does that mean? I'm aware about the different float types they have here. Like fixed, and there's one called half. Uh, Need to figure this out. Actually, let's go back to this. In both the cases, you're sending the lighting data and we're sending the surface data. Mm, yeah, this is the one. Yeah, we're sending the alpha and the lighting data, right? Yeah, this is the definition for the method we're looking for. Yeah, it doesn't go inside that one. It goes inside this and calculate lighting color. Then this is another trace we've got. Okay, all right. This is actually where we were originally. Yeah, it comes. It comes here. Definitely comes here. Albedo is just one. Not sure what happens if two half three gets multiplied. I'm just gonna ask AI. Actually, I'm just gonna Google search Unity shaders HLSL half three multiplication. Yeah, it's a component wise. So it multiplies component by component. Yeah, so this will be basically zero, isn't it? Or maybe it always goes inside one of these. Yeah, unless it goes inside one of these, this will always be zero. We don't have this, we don't have this, we don't have this. This and this looks like they're doing something. But I'm gonna use this main light color. Because that looks, it has the word main in it. It's calling me. Let's find out if this is. Alright, there's gonna be a lot of calls. And no definitions. Yeah, it's gonna be a lot of calls and no definitions. So I think it's inside BRDF. Could be wrong, let's see. Nope, it's not inside here. Alright, then what else can it be inside? We'll have to go back on top and then, oh, it's inside debug 3D. Debug 3D. Or it can be inside real time lights. I'm gonna see if this opens up like from the editor. Doesn't open up. I'll have to manually open it. What is it called? It's called real-time lights.html. Real-time lights.html. A lot of calls, but then yeah, I think it's under debug. Let's go back to this. It's inside debugging 3D. Where is that? Debugging 3D is inside debug. Yeah, I don't care about this debugging.3D because I don't think so. We need it, but I just want to be assured that uh, my assumptions are right so that I can move on. Actually, it's not here. It's not here. It's not here. It's somewhere else. Maybe it's here. No, it can't be here because if it was here, I mean, it has to be. It's a general function. It's not for particularly global elimination. So I don't think so. It's here. Actually, I'm just gonna use the search feature here and find. Yeah, it's not gonna be able to find it unless I have the file open here. Because that's just how this works. Yeah, then I'll open all of this. Good thing is they're all inside one directory. I have to open global elimination. What a refresh. Global elimination also does not have it. Real-time lights also does not have ambient operation. Ambient occlusion also does not have a definition. Debuffer does this have the definition? Debuffer also does not have a definition. Then if it's not inside all these includes, then means it's inside here. Maybe. Yeah, it can't be inside here because it show in our search. It's not here also. Hmm. It's not inside here. Let's go back to our forward. Oh, it can be inside here. No, it can't be inside here. Otherwise, again, show here. Maybe it's inside the code or a chest. Core looks like it's a generic thing. Like it's core, but like it's a because it's a core, won't have anything particular. It will have everything in general. Oh my god, there are so many clues. I have to go to each of these and try to find it. This is the forward pass. Is it a dots thing? Uh, should get it inside common. Where is the common file? Was it core? Yeah, it's a core file. Is it run? I'm not in the right parent directory. Is lighting feature enabled? Can't find it anywhere. It's not inside common. Is it inside VSD? It's not inside VSD. Is it inside API? Is it inside of here? Alright, I'm just gonna see the dots file also. Oh wow, they have uh, for each of the APIs they have a thing. Hmm, this is interesting. But I'm gonna not get into that rabbit hole today. Because we have more important things to do. We have to find this dots file. Is it a debugging thing? Fine, let's ask AI if it can do this. Can you find this function definition? It's a shader related function, so we need to search it inside a .hlsl file. But it failed. Is it because I don't have the credits? I have to update my version. It's a debugging common. It's inside a debugging uh, common.hls. Yeah, I don't think so. That's the main writing function. I don't think so. Then that's where the coloring happens. Um, Maybe it happens inside the G buffer. Well, let's ask AI what's a G buffer. What's a G buffer? Geometry. Yeah, it's a screen. Okay, it's using defer, but we are using forward. Maybe this is not what we need. Are we using forward? Let me check. Yeah, we're using forward. That's not where the coloring happens. It's probably inside this. Because other than these two functions, the others are for very particular things, not for coloring the object. This is all that we have. I'm gonna try to find it in this. Yeah, this is where it has to be because we have all the traditional methods. I mean, I'm sure they are. I mean, they have to be there in each pass. So that's not what I meant. But yeah, this looks like. It sounds like a file which would be concerned with rendering stuff. And fragment shader is where all the color things happen. And we are getting the color here. And then we are doing a lot of things with it later on. So we are getting the color here. So I mean, we are doing all of these things. Then this gets called, and that goes inside, and that is inside this. I need to find that bookmark VS Code extension that I found before. Right, do I still have that bookmark? That extension? I don't. Now I'll have to restart this, right? Alright, we have done a bookmark here. We'll do a bookmark here. I think what this is basically just because I'm seeing this alpha here. I think this is just for alpha related things. but the actual lighting data is coming in from somewhere. Actually, I don't know. Let's see. What is it called? It is called calculate final color with two parameters. Is that half? That has to be a half three. No, no, that can be a float, a normal float, normal half. Then this calls that, right? You have the lighting color. Yeah, it takes the lighting data but does not do anything with it. I mean, it does all of this. This is where it's at. This is just for the editor, actually. Yeah, it makes sense that they'll put it in the last. So we have to go back. I've actually understood what this is doing. So what happens is the final uh, lighting and all the shading related stuff happens here. Like it's already stored inside lighting data, and then this function just checks all the debug related info, all the debug related operations. This is what it does. So we have to kind of go back a little bit and find. Uh, yeah, it could be this. There has to be a function for the main kind, sort of a function. Not a main, but like a function that's responsible for the lighting. And it is one of these ones because BRDF is a lighting model, and that's how and that's why like now, that's where you get the that's where you would get your lighting data from. It would be only out of a model. So BRDF is a type of a model, and then there's more models like Lambertian and Blinfong. I think I don't know if Blinfong is a model. Yeah, I think Blinfong is a model, and BRDF is also a model. Alright, so let's see this. Alright, that's an initialization, and I'm assuming this is inside that. I really want to get into BRDF, but it's fine. Copy this, and I'm gonna go inside. Oh shit, there's so many files. I want to close some of these. I'm gonna close this, and this. Alright, and inside this, I'm gonna look for that function. And yeah, okay. Alright, how many definitions do we have? We have one legacy one here. There's one inline. There's another inline. Let's see which one we're using. It's with two parameters. Could be that one. I didn't know you could do in out here. In shader, in like the HLSL, I didn't know you could do in out. Maybe it has to be inline if you want to use these. I don't know. Oh yeah, this then it goes here. This is the one that probably gets called, and then this calls this one in return, which has one, two, three, four, five, six methods. And then let's go back on our lookup for the actual. Wait, is it? No, it's not there. I just wanted to see if it's the direct one. So it's not a direct one. It is, yeah. I think it is this one because this is also inline. Did it have out for the last parameter? Okay, where is that inline? The other inline. Yeah, this is the one. Yeah, that's an out. Uh, what is it called? That's an outfield. So I think we found our main initialize our BRDF data method function, and it is this one. So let's check uh, what's happening here. So we have the albedo and all the other types of shading stuff. And let's see where this function actually ends. Not that one, this one. It ends right here. With it calls this one. So we are not concerned with specular, not concerned with metallic. We have to go directly into this one. And that is, yeah, I think there are only two of these. There are only two of these direct functions. So I think it is this one. So it comes here, makes this as the, oh, this is the output object. So yeah, it's kind of remaking this here, reinitializing it here. Wait a second. Yeah, it's reinitializing it here. Um, yeah, but why is it reinitializing? I don't know, but yeah, I think albedo wasn't inside that data structure then. It was passed on from surface data. So yeah, so this is the output object. We're gonna calculate the final albedo and put it here. Uh, yeah, so it just assigns the albedo. That's all it does. Because specular and all these things are happening somewhere else, right? Yeah, they are happening here. So yeah, it just gives you the color. It basically returns the color, calculates the specular, the reflectivity and everything, and gives you the final color. Uh, but it does not have the lighting stuff that I was looking for. Like which areas of the model will be dark, which areas will be lit. How does it calculate that? Is it inside? Yeah, it has to be inside specular. Is it? Is it inside specular? Direct BRDF. Based on minimalist cook tolerance, slightly different from the original derivation. The the setup that we are using, the setup that we are using is which one is it? Is it the metallic one or the specular one? It's the metallic one. So it goes inside the metallic. Yeah, we'll have to start tracing those calls. These calls we'll have to start tracing now. I just want to come back to where it must be calculating the, the the fall of the light on the surface of the model. It does not look like it's happening here also. This is just for the metallicness. And this is just this assigns from this data, like from the surface data to the BRDF data. Where are these functions getting called? The other ones, this one and the other one. Alright, I'm gonna look for that now. I'm gonna go back to my forward pass. I'm gonna go up. Actually, it's not here, right? It's inside this. Yeah, it's inside this. Yeah, this was just an initialization. Yeah, this one we don't need. This one we don't need. Not need. Mm, do we need this? Yeah, this just gets the main light. We don't need this also. We need to come down mixed real time and baked GI. Note, we don't apply AO to the GI here because it's done in the lighting calculation below. This is where it's getting the lighting data. So it got the lighting data and gets the color here, and then somewhere lighting physically based. Is this the function that we're looking for? Yeah, see this is a get function. This is definitely not what we're looking for. Mm, and that just gets additional light colors. So I think this is the one. Global illumination, create lighting data. Yeah, I'm gonna check these two. Actually, I'm gonna check. I just want to check it. Are we gonna? Are we only going to find the calls, or there is a definition? There is a definition. What does it? Oh, it just constructs the. It just constructs the data. Let's go here. It's gonna be inside that file, huh? Yeah, it's gonna be inside that file. I'm gonna open that. Hmm, we're looking for that call, right? I mean, I could just copy this file and duplicate it, and then modify this one. Just this. Just put the what is it called, half immersion and diffused color, the warp diffusion here, instead of in instead of these other files. Because global illuminations are like that. Those solutions are for global. At least half immersion is for global illumination, and warp diffuse kind of looks like it's doing that, but yeah, it's actually for, like, I've seen people using it for subsurface scattering instead of implementing a full-fledged subsurface scattering shader. They use warp diffusion. We don't need this. We don't need this. Not this. I mean, I don't know if you need all that or not, because I'm not checked how many. There are so many parameters. 1, 2, 3, 4, 5, 6, 7, 8, 9. There are 9 parameters. So it's definitely not this one. It can be this one. It can be this and this or that, right? One, two. Sorry, one, two, three, four, five, six, seven. One, two, three, four, five. Was it really that many parameters? One, two, three, four, five, six, seven, eight, nine. Yes, there are nine parameters. Nine parameters. Where is this function? One, two, three, four, five, six, seven, eight, nine. This is the. Is this the one? Space UV view direction world space. Yeah, this is the one. What does this have? Let's check. What is NOV? Yeah, this looks like where it's. This is where it looks like. This is what gives me an impression that this is where we have to put our code for half immersion. But I just want to see what kind of a thing this is using. What is NOV? Normals? Is it like the view world space normals? It's a dot product between world space normal and the view direction. Okay. I mean, I understand what this is that is doing, but I don't know why they've done it. Oh, it's for the Fresnel. Okay, that was for Fresnel. That's okay. What is environment? I keep seeing this word clear coat. What does that mean? Let me look this up. Uh, you know what? I'm gonna put it on my LinkedIn that I'm doing this live stream. Alright, I'm gonna go off for a second and then I'm gonna quickly come back. 1 second, guys. I'll be right back. How do I share? Okay. I'm just gonna create a LinkedIn post quickly. Yeah, I'm just gonna quickly create a post and I'll be right back. As in, I'm here. I'm not gone anywhere. I've just switched off my screen. I'm gonna ask Gemini to create that, and I'm also going to do the other thing that I'm gonna. Here, I'm gonna create a nice post quickly. किधर से Okay, I can't record because my OBS is getting used for streaming. Let me open another OBS and see if it works. Actually, I'm gonna just not make a video. I was thinking of putting a video, but I don't have time to put a video. I'm just gonna create a. Just gonna take a screenshot and use that. I'll take that. Um, yeah, it's gonna be stored inside my screenshot folder, but I'm gonna still put it here. Okay, wait a second. I'm gonna save this PNG. Call it head. And then I'm gonna also record my. I'm not recording. I'm just gonna put it. Where is it? Where is it? Where is it? Is it inside my visual test? Oh my god, this scene has not been opened for such a long time. I'm gonna take a screenshot from the game. Wow, I took damage for the big part. In wire and wire. Save and then wanna open. Just gonna do a quick edit on photo P. Where is it? Where is it? Where is it? Where is it? It's inside pictures, screenshots, and copy this, put it here. And then I'm gonna get some screenshots from the comic, hanging balloons. Gonna get this one. Open image in new tab. Close some of this. Actually, I'm gonna have to pick a better one. Wait a second. Wait a second. Uh, yeah, I'm gonna put some of these. Some of one of these. I know you guys can't see anything I'm doing, but I'll be right back. I think this describes my game the best. This and this. So I'm gonna copy this image, put it in this. Okay. Okay. Then I'm gonna go back here. So I copy this image, put it here, then this one in front, and then scale this up. Now draw a line here. Hmm, where is the brush? Oops. And then I'm gonna just save it, export it as PNG, and then I'm gonna use that. Linked in post. Can I preview this before posting? Mm, today I'm working on What's on my thing? How do I get the link to this live stream? Hmm, must be all the way down there. Okay, I found it. I need this YouTube link. Alright, I'm gonna close this now. I'm gonna close this now. I'm gonna close this now. And I'm gonna start the screen again. Yeah. There you go. There you go. I'm also gonna close this and not gonna close that. I'm gonna close this. Close this. Do I have the chats open? Yes, I do. But yeah, I want by YouTube. Uh, I wanted my YouTube Studios live dashboard. Where is it? It's gone. Okay, maybe we'll. Second. YouTube Studio, your channel. It has to be inside your channel. Can't find it. Is it inside here? It's can be that. Yeah, it is this. All right, we're back. Let's get back to work. All right, uh, we're trying to do half inversion and warp diffuse. All right, what is this NOV? This is definitely normals of view, something like that. Let me just quickly find that. How do we undo this? Undo in new win. All right. All right. So, all right. There are two functions definitions, but I think it's this. This is the main one. Then we have to find a place where we can put the what is it called? The half numbered. So it has to be somewhere where they're taking the direction of the light and the normal, because that's where I mean, if at all they're using Lambertian, which it doesn't seem like they're using Lambertian. So I know this is normal. Sorry, this is normal, and that is view. So this is normal of view or something like that, and we are and that they're doing for Fresnel. So this we need not touch. But then there is this, and then there is indirect specular. This also we need not touch. This could be what we can touch. And the other thing is, yeah, this could be what we can touch. Now we have to find this function. Environment BRDF. let's see where that is defined. Yeah, it's defined. Okay, that's a clear one. Yeah, it's defined in the same file as the other function. And then this calls a speculator. Okay. This blends the, yeah, this multiplies the indirect diffuse with Biardier diffuse. Let's see what are we sending in the as indirect diffuse. Sorry, it doesn't send this. What we are sending here. Okay, this is the baked GI thing that we're sending. Baked GI is a float 3 that we get from the input data. I feel like I want to trace this big GI. Is it this? Is it what we do here? Is that what's called big GI? Let's see how this input data is formed. Uh, what is the data type? The data type is input data, and it's formed inside here. I bet it's formed here. Hmm. We have to find big GI. Input data dot big G. Actually, I don't remember how. Yeah. All right. So there's a separate function for that. Okay. There's an if case, irradiance, screen space, irradiance, dynamic light map on, light map off. Yeah. So basically, light map off. And if you are not using any probe, or we have probes defined, then so if light map is off and we have probes defined, then it comes here. We don't have this. I don't know if we have this or not, and I don't know about this as well. But then it comes here. Sample GI, input static light map UV. Okay. Mm, all right. Let's see what is the. This looks like a default case, like a major. I think majority of the times it will come here. Like this must be the default case, right? The default settings. Uh, but I don't know what is screen space irradiance. Is it something over here? Baked GI, okay. Real-time global illumination, real-time and normal lighting types. Alright, so there is both of these are active, and I'm not baked lighting for this, and I don't want baked lighting at all. Everything is real time, so I don't think so. The light map is getting used. We had a we had one for the light map, right? But maybe this dynamic light map is basically real time GI. Pre-computer lighting provides diffuse real time. Okay, it's definitely not this. It's definitely not this. Is there something over here? What is screen space irradiance? Okay, I'm just gonna find this function, sample GI, and I bet it will be inside this. Oh, it's not inside here. Sample underscore GI. Is it inside lighting? It's not inside lighting because otherwise it would show in the search. Because we have lighting open here. I think this is since it's calling, since it's defining sample screen space GI to be sample GI. Screen space GI. Yeah. Load texture to the X. Screen space. Okay. Do we seriously have this inside this file? Load texture to the X. Okay. Now we have to find load texture to the X. That's an absolutely new function. Low texture loading function I've come across. But we are loading this function. Screen space irradiance. I'm gonna look for this. Unity screens space irradiance. Says it's for that. URP. I mean, this can be a common file between both of the RPs. Actually, it can't be the same file between both of these RPs because, uh, yeah, it can't be the same file between both of the RPs. But I don't know which case we're going inside. Which one we're using here. Let's. Is there a way to find that? See. Hmm. Specular highlights, environment reflection. Off. I'm gonna switch that off. Uh, yeah, we don't need that. I don't know if we need this or not. Mm, Alright, we're looking for some traces of irradiance or GI, but I don't see any of that here. If I just select this shader and go down here, to understand which one it compiles, is is there a way we can understand that from this? Because if there is a way like that, then from all these preprocessors, all these properties, I don't. Okay, yeah, I will obviously, I won't obviously see irradiance because the material didn't show it also. Mm, mm, Not overridable. Let's see if there's a GI here. There's nothing for the GI here. Let's see if there's something for GI over here. There is dynamic light map on, and that is overridable. And there's light map, but we are not. Okay, this can be the other light map. I mean, yeah, I don't know. Let's see. Uh, there's definitely no GI, but there is screen space irradiance, and it is overridable. So I guess we are using screen space irradiance. It comes here, and that is a property or a texture that we're loading somewhere here, right? This is a texture we're loading somewhere. I saw this. Maybe it's inside here. Paste. Okay. Maybe it's over here. Yeah, it's here. Where does it get this from? Needs a position because it's screen space. It needs a float too. This is a sampling point, and that's the texture. But where is this texture? Space irradiance. Okay, let me search it on Google. Unity underscore screen space irradiance URP. Open source screen space part tracing for URP. uh, Open source. I don't want all this. Hmm. Are we using enlighten? How do I know if I'm using enlighten or not? It's for the light mapper, but we don't have baked lighting. I think that texture just gets loaded, and we don't need all of this. I'm not gonna use. Does it drastically change anything? Doesn't look like it changes anything drastically. Yeah, and we don't have this, so that's great. As for the environment, if I do this, does it generate anything for that? Generates light data, which is not inspectable. But yeah, I'm just gonna hide all of this. Um, the real-time global illumination. Let's URP lighting settings real-time GI. Why is it giving me all this? Alright, uses a middleware solution called that. Screen space irradiance. Is that how you spell irradiance? कहाँ है irradiance. Wait, I'm just gonna copy from here. There is none actually. Delete all that and search again. Glossary irradiance project. Light map parameters. So there's a light map parameter settings, but because I disabled all of that, I don't have I that got disabled. I go in this new. There I'll find irradiance. So basically, I have to just disable this, and then everything is sorted. Now I'm going to go to my visual test. Oh, so yeah, this is a global setting, right? It applies even to this. But if does it start looking better if I do this? If it looks better, then I want to continue using that. I'm gonna wait for this baking to happen. Uh, are any one of you alive? Not that I'm dissatisfied with the look right now, but I just want to see if it looks way better. If it looks way better, then I'm gonna use it. Alright, I'm gonna be right back. Not sure if it's that good. Let me check. In the game mode. I think it's better. I don't know actually. Okay, I'm gonna take a screenshot. I'm gonna stand here at that cube here. I'm gonna take a screenshot at that. Actually, I'm gonna keep my question down and I'm gonna take a screenshot. And then we're gonna do a side to side comparison. Let's run it back. Disable this. I'm gonna take a screenshot here. Okay, if I take this, then it's gonna delete that. Is there a way I can open this in Paint? No, I think. Oh, actually, it wouldn't have been a problem because it opens a new window, right? Every time you do this, it opens a new window. Okay, never mind. I have it here. Alright, I'm gonna go back and disable this. And all of these settings are now irrelevant. I'm gonna regenerate lighting. Let's see. Hmm. So far, no, I can't see any visual change. Is there any change at all? Hmm. There does not seem to be any change. Actually, it's all the same. Okay, there's no change in this. Even the further objects has no change. So I'm gonna close this. And I'm going to come back to this game and play. Alright, let's get to our spot here. Oh god, I forgot. Was it? Yeah, I think it was like this. I don't think so. These settings do anything if you're using real time lights. 21, 27, 34. This is the this is the current one. Okay. All right. Yeah, I don't see that much change. Not much change. Actually, I can't make anything. That's that is different in both of these. Is this a little brighter? Maybe that's because of the angle. Mm, yeah, this has little shading here. This tree, this white patch. It does not have it here. Maybe that's because of the angle. Who knows? Because all of these steep trees have that. I mean, over here as well. This tree has a bit of lighting here. There. So I don't know then if that setting does anything if you're using real time lights. Maybe I can just go a little behind and try this. Yeah, it is more towards the left, isn't it? And where was the cursor? Pause this. I'm gonna go back here, and there's a good amount of distance here. Do we have? Yeah, we have a good amount of distance. Does that tree have this? It's definitely darker here. Why is not? Why is it not moving now? Yeah, it does have um, that light patch there. We just have single light in this entire scene, so maybe that's why. I don't think so. We need to worry about this right now. So let's go back here and in our lighting and wherever we're sampling the GI. So this is not. So this is not what you're using. Dynamic light map on. Is this? Is this? Is it this? If it's nothing, then it is this, right? Um, yeah, if it's nothing, then it's this. What is it? Yeah. Mm, nope. 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 So it is this. This one. Sample SH pixel. Okay. Sample SH pixel. Mm. SH pixel evaluation. Depending on target SH, sampling might be done mixed or fully in pixel. We sample SH matrix. What is SH? What does SH mean? Let's ask AI. I use this one. What does SH mean in sample? Oops, sample SH. Spherical harmonics. SH AR, SH AG, SH AB, red, green, blue. Mm, hmm, okay, let's see. Okay. don't have. Hmm. Yeah, it says Unity underscore SHA. That makes sense. Basically, the break G highlight is zero. Where is our function gone? It's right here, and sorry, it's right here. This is yeah, this is the one. Yeah, so GI is basically zero then, because I can test that by multiplying this by. Oops. But I can't make a change in this 'cause it's a package. Okay, so I think it's the right time to kind of extract this texture into our own files. But before that, I want to find that global illumination, this method. Yeah, I think that was inside here. 1, 2, 3, 4, 5, 6, 7. Somewhere we saw that function, right? I want to make a change here when we extract this. Because if that's not working, then basically we're fixed. We know exactly where to put that. I'm gonna put it here. I must clear that. So let me find where is this. What's clear code? In clear code is a rendering feature. Realistic materials like that. Okay, that's crazy. You don't have you don't have to worry about that, right? Hmm. Yeah, we don't have to worry about this. It goes directly in this for us. We are just gonna put that here. We're gonna put our Lambertian stuff here, half Lambertian stuff. Global illumination, global illumination. Bookmark this, and I'm gonna bookmark that line. Where is it? I'm gonna bookmark this. Where is this function? Yeah, it's called over here. And then we're gonna test that here. I'm gonna write a debug. I'm just gonna write some code for debug purpose to check whether this is zero or not. It should be zero according to the AI, or it should be a small value. Let's see. I'm gonna multiply it by yeah. This has to be a float three, right? Like a half four or something. Also, let's see this lighting data. It has to be inside lighting. It isn't. It's a half three. I'm gonna multiply it with a half three and see what's the answer. Hmm. Do you see all this in the frame debugger? If you can see all of those values inside frame debugger, then you're sorted. Oh, that's just a shadow map. Yeah, these are just shadow maps getting drawn. Blit color left. Okay. I don't know what this is for. But then we have this. Draw depth normal. Okay, that just draws the normal, I think. And then the screen space, ambient occlusion is basically white. Then we're drawing the opaque objects. I don't know what that is. Is it like a upscaler? Maybe. Then we draw transparent objects. Then we do bloom and then Uber post. What's an Uber post? Post processing. Do I have any post processing? I do. It still doesn't Uber. But yeah, we don't need to care about all that. We need to see this. Because this is the dead shadow. And and we have to check irradiance, and we have to check whether we see those data structures or not, like lighting data and stuff. I don't think so. Those will be here, and they are not here. So far, we've not found it. Yeah, these are all the properties. Wow. Mm, is there anything related to the GI? These are like 256 values inside. There's nothing GI related here. I don't think so. That gets shown here. Yeah, what we're looking for is the skin material that is called the skin. That's the tongue. This is the one. Mm, okay. So what we found is that maybe the GI is not applied, and we've also found a couple of potential locations where we can put our half Lambertian logic, I guess. Uh, not sure which one we're using. Over here. 1, 2, 3, 4, 5, 6, 7 cards. 3, 4, 5, 6, 7, 8, 9. Not this one. 1, 2, 3, 4, 5, 6, 7. This is the one, but it calls this one. Is 3, 4, 5, 6, 7, 8, 9. One to go. And there is this one. 1, 2, 3, 4, 5, 6. Here in here. 1, 2, 3, 4, 5, 6, 7. Okay, so there are two of these which are 7. 1, 2, 3, 4, 5, 6, 7. Alright, how do I know which one it's called? This returns a half 3. And that has a boolean in the end. That also has a boolean in the end. How do we know which one gets called? Where do we find which one it's called? I mean, all of these call this 1, 2, 3, 4, 5. Not really, actually. Because I can go to the one with 9, 5, 6, 5. 6, 7. I think this is the one. And here you can see they're doing the things. Normal and the dot product. So the word space now. And the word space light. Okay. there a way we can change the attenuation here? Attenuation. Uh, because it has these values. It's not there. New light map parameters. New light. Do you have attenuation? You don't. Mm, when we could trace it. Also, we'll have to figure out how this light object is getting formed. Mm, I'm sure we're sending it from here. Are we sending it from here? We must be sending it from this universal fragment PPI. Main light. Alright, where is this data structure? To find. Is it inside BRDF? I see writing data, but I don't see light. Hmm. I think I found where we can put it. Uh, is this lighting physically based? This looks like this looks similar to how RAM version does it. Where is that post? What's readings in shaders? sending the third parameter, which is the light. How do we find that? Yeah, third is light. Light color and light direction. So this is the incoming light, the main incoming light. We're doing a dot product and then we're using saturate. I don't know what saturate does. Yeah, I think it's not normalized. I think it's normalized. Let's see. Okay, let's see where this is getting calculated. PRD of data dot diffuse. play some Deadlock now. How do I change this? God, not the layout. I want to hide stream info. Close this. Say Deadlock. What I call Deadlock. Deadlock. Open. Deadlock is the best game ever. So if I refresh this, okay, so Twitch is sorted. How do I sort this out? Mm, I'm actually gonna close this, and then I'm gonna go. Okay, thanks. Yes, here. Mm, Deadlock is the best game ever. And then I'm gonna go calm down. Say Deadlock. Alright, we're gonna play some Deadlock and then call it a day. Alright, let's go. There's a lot of lag. Maybe it's because I'm streaming. There's a streaming mode, right? Okay, it does not affect the doesn't affect the bandwidth or anything. Yeah, there's a lot of lag and like it's all network related stuttering. Oh, my FPS has dropped. My FPS has dropped. Okay, can I play in this FPS? If I can't, I mean I can't. I can't. This is lesser than 60. I can't. With all the particles and all things going on during a fight, this is gonna drop even low. I think I'll need a more beastie PC to play and stream. Alright, I'm gonna call it a day, guys. GG's.